Hey, what's up, guys? It's Sebastian here, and this is going to be for a specific student that wanted me to record this so that way she can save time. So, without further ado, let's get started. So, first, we're going to tackle section 1.1, which is going over limits. So, for the first question, it asks us as x approaches 1, the value of 2x plus 7 approaches, aka equals 2. So in order to solve this, all we need to do is plug in the 1 into x. So 2 times 1 equals 2 plus 7, and that equals 9. So the answer for question 1 is going to be 9. Okay, so now what I'm going to do is I'm going to stop share from the iPad, and I'm going to go to desktop 2. All right. So with this question, the notation blank is read the limit as x approaches 2 from the right. Choose the correct answer below. The answer is going to be B. So the limit as x equals 2 plus. That plus sign at the top right, as if it was in the squared sign or a cube sign to the power, this plus means we're approaching 2 to the right, 2 from the right. So numbers like 2.1, 2.01, 2.0001, numbers that are really close to 2, but just a teeny bit bigger. Next up, question 3. The notation, the limit as x equals 5 negative fx is read as, and the answer for this one is the limit as x approaches 5 from the left of f of x, which is b. This means a number that is slightly less than 5, but still closer to 5 than 4. So for example, 4.9, 4.99, or 4.999. Numbers that are not quite 5, but they are really, really close. So for question number 4, use the graph of f to find the given limit. When necessary, state that the limit does not exist. So the limit as x equals 4 is, so what they're asking is when x is equal to 4, what is y? So if we look closely at the graph right here, you see when x is 4, what is y? Well, if we go up 1, 2, 3, 4, 5, 6, and you see right here at f of x, when x is 4, y is equal to 7, that is our limit. Next, we're going to do the same thing with x approaching negative 6. What is the limit here? Well, if we look at the graph, you'll see when x is equal to negative 6, that limit is equal to the number 0. Now notice here that there is an open circle, which means that this is not going to be continuous because you're going to have to pick up a pencil. But the limit is going to be 0. So when x is negative 6 on the graph, y is going to be 0. That's what these limit questions are essentially translating to. Next, we have the limit as x equals 1 from the left. Now you got to be careful with this one because we see 3 points at x equals 1. We see a point here, we see a point there, and we see a point there. But which one is 1 from the left? Well, we have to look at where these points are coming from. The top point here at, let's say y equals 3, that is coming from the left side of the x-axis. And right here, when x is 1 and y is 0, it's just there on its own. And then right here, at x equals 1 and y equals negative 1, that point comes from the right side. What they want is 1 from the left. And at that point, we have y equals 3. So there's your answer. Next, we have the limit as x equals to -3. So this one, you got to be a little careful because there's 2 points that are x equals to -3. We have a point here, which is 1, and we have another point here, which is 2. But which one do we pick? Well, we have to look at the one where there's a line on the graph. And with this line on the graph, you will see that y equals to 1. So therefore, that's going to be our limit. Next up for number 8, the limit of f of x when x approaches 0. Let's take a look at that. So when x equals 0 on the graph, you will see that y equals to -1. So essentially the point I'm hammering into your heads is that when it's asking for what the limit is as x approaches something, what it means is when x is blank, what is its y coordinate on the graph or in the equation. That's what it wants to know. And for this problem, it's at -1. Next, we have the limit as x equals to -4. Well, you see with this problem here, you will see that at -4, the line continues to get closer and closer and closer and closer to -4. But as you see, it doesn't quite touch -4. It's getting really, 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 really close as the nines just keep adding up decimal place after decimal place. But it never quite touches 4. It never crosses that line. It always stays on the right side of -4 and it never crosses the left. So because of that, the limit does not exist. Even though it may look like it doesn't quite cut it. Okay, now for number 10. So what I'm going to do in my iPad is I'm going to write down the equations. So we have f of x equals the absolute value of 2x plus 4. And what we want is the limit as x approaches -2. And then we also want the limit when x approaches -4. So let me go back to these. Okay. So now let's stop sharing my Mac screen. Let's go to AirPlay. All right. Hold on, let me. Okay, perfect. Okay. So now let's see. All right, perfect. Okay. So we have the absolute value of 2x plus 4. So first we're looking for the limit when x approaches -2. To make this simple, all we need to do is plug in the -2 into the x. And that's going to make this a -4 plus a 4. And that's going to equal the absolute value of 0. And the absolute value means whatever number is inside those brackets automatically gets converted to a positive. So that will make the points -2, 0. So the limit as x approaches -2 in this case is going to be 0. Now, what about when x is equal to -4? Well, in that case, it'd be 2 times -4, which equals to -8 plus 4, and that equals the absolute value of -4. Now, again, like I said a second ago, any number that's inside the brackets automatically gets converted into a positive. So therefore, when x is equal to -4, the limit is going to be 4, aka our y coordinate. So now I'm going to stop screen mirroring. So I'm going to stop mirroring on there. Stop share. Let's go back. Alright, so now that you know how to find the limits of x equals -2 and -4 or whatever numbers you get, now the question is, how do you graph this? Well, seeing that when x equals to -2, y equals 0, you could make a point right here. Then when x equals to -4, you will see that y equals +4. So right here, these 2 points alone with the V-shaped points tool, that is going to be enough to finish the graph using the 2 points that you just found. Next up, for number 11, we are going to graph the given function. So it's going to be g of x equals to -2. I mean, not -2. So it equals to g of x, which equals to x squared minus 6. And so the first portion wants us to choose the correct graph below. Now, if you have a TI-84 calculator on deck, then this is really easy. All you have to do is type in the equation into the y equals portion, then hit graph. And after that, you just pick the correct graph. So now, after you choose the correct graph, now we have to find the limits. So for this one, they want the limit as x approaches 0, and they want the limit as x approaches 2. And just like all the other problems we did before this is pretty straightforward. So let's say we were to do 0 plugged in to the x. 0 squared minus 6 equals -6. So therefore, you will see here that x is that g of x equals to -6. Then for 2, if we plug in 2 into the x, then 2 squared, that equals 4, minus 6 equals to -2. So the limit of g of x when x approaches 2 is -2. All right. So next up for number 12, it wants us to graph the following function. G of x equals to 8 divided by x over 3. So if you have a TI-83 or TI-84 calculator, then graphing this is going to be pretty straightforward. If not, you can go online and use some graphing software like Desmos or Mathway in order to graph this easily. So you can do that. So then once you graph it, you choose the correct graph. Now, the main portion of the work is, of course, finding the limits. So to find the limits, so what they are looking for is what is the limit as x approaches to -2? And then what is the limit as x approaches to -3? So first, they want us to find the limit as x approaches to -2. So what they want us to do is to plug in that -2 into the x, so then we'd have 8 over -2 plus 3 on the denominator. The -2 plus 3 becomes a 1, and there's going to be an 8 on top. So therefore, our limit as x approaches to the -2 equals to 8. But what about when x is approaching -3? Well, if that's the case, then we have a problem, because -3 plus 3 on the denominator equals to 0. And anytime we divide a number by 0, it is always undefined. It is a straight vertical asymptote line. So the limit does not exist. Now, if the 0 is on the numerator, for example, and any other number besides 0 is on the denominator, well, 0 divided by anything except itself is 0. But any number divided by 0 is always undefined. You cannot divide 1 up to get 0 ever. You cannot divide 5 up into different pieces to get a 0. You cannot do that. That is impossible. Okay. Now for this one's a little tricky. So for number 13, they want us to graph first. So we have f of x equals 3x minus 4 when x is less than 3, and then x when x is greater than or equal to 3. So we first had to find the graph, and then later on we had to find the limit as x is approaching 3 from the left, 3 from the right, and then 3 head on. Now let's look at the equations themselves. The 3x minus 4. So let me stop sharing my iPad. So we have 3x minus 4, and then we have x. So what we're going to do is I'm going to share via AirPlay one more time. All right. So for 3x minus 4, so when we say y equals to 3x minus 4, we first want the slope. So the slope is going to be the number that is the integer next to the variable x, and that slope is going to be 3. Meanwhile, the y-intercept, so when we make x equal to 0, then y is equal to -4. As for x, it's pretty much just a diagonal line. So when x equals to 1, y equals to 1, blah, 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 it's pretty straightforward. So when it comes to the 3x minus 4, because the slope is 3 and the y-intercept is 0, -4, if we go back to the problem, hold on one second, let me make sure that I'm sharing the correct. Okay, perfect. All right, so for the 3x minus 4, here is why the answer would be this graph. So for the 3x minus 4, as I said earlier, the slope is 3 and the y-intercept is 4. I mean, the y-intercept is 0, -4. So when x is 0, y equals to -4. That point is right here. And when the slope is 3 that means we go 1, 2, 3 points up on the y-axis and 1 to the right. And that'll get you right here at the point 1, -1. And then it's going to repeat over and over and over again. And what you're going to notice at the top here is we have an open circle at the value 3 for x. And the reason is because it is assuming that we are doing this for any values of x that are less than 3. Therefore, it's going to be an open circle right here. But then what about for x? For x, we are assuming that it's going to come from the right. And when that x equals to, let's say, 3, for example, then that y equals to 3. And these numbers are only concerning, and this line stops here because we are only concerned with x values that are a bare minimum 3, greater than or equal to 3. Any numbers less than 3, like 1s and 2s, we are not factoring those for this line right here. That's why we pick this graph. So now what we're going to do is try to find the limit. So let's say we're trying to find the limit for 3 from the left. If we were to choose this route, here's what we would do. We would plug in the 3 into the 3x minus 4. So we would do 3 times 3, which equals to 9, minus 4, and that equals 5. That's going to be the limit if we do 3 from the left. If we do 3 from the right, the answer is simply 3, because 3 from the right is a number that is slightly bigger than 3, but not close to 4 in comparison to 3. So like 3.1, for example. If we do 3 from the right, and we just plug in a 3, then that x turns into a 3. Now, what if we were trying to find the limit as x approaches 3 in general? Well, if we look at the graph from the first part, you will see that the limit does not exist, because for these 2 points at x equals 3, there are 2 different y points. For the 3x minus 4, the y is going to be at, let's see, 1, 2, 3, 4, 5, 6, right? Or let's see, 1, 2, 3, 4, 5. So it's at 5 here. And then right here, what you're going to see is that for the second point, when x is 3, y is 3. So because neither of these graphs meet in the middle, you will see that the limit does not exist because these 2 points on the graph do not intersect. So therefore, because 3 from the left and 3 from the right do not share a y coordinate, therefore the limit does not exist. I'm going to stop here for this video, and I will make another one to finish off section 1.1. I will see y'all then. Bye.